Hello everyone. I am going to start explain you about file I/O, low-level file I/O in C today. We learn how the file I/O happens, how the process executing in the memory, user space memory, is able to access data from files stored in the secondary storage. So basically, what we have to do is this. We will have some programs executing in the user space, and those programs will try to access some data in the disk, secondary storage disk. Suppose you have some program process executing here in memory. The process executing here in memory. So this is memory. Memory means RAM. In the secondary storage, on the other hand, in the secondary storage, there is some file kept. Some file. In the file, there is some data. Now this is in the secondary storage, but the file, the executing process in the user space, the process that is executing in the user space, that process cannot access the secondary storage. In between, there is some kind of virtualization, something called virtual file system. You will have something called virtual file system. In virtual file system, you will have entry points access to these files. Okay. Now what we have to do in our process is we have to create some kind of access through these entry points into the file so that we can access the data and move data through this to the process, or from the process to this file. Okay. Now the process that is executing in the user space, this process is active, alive, running entity. Process is active, alive, running entity, whereas the file in the secondary storage is a passive entity. Okay, passive entity means it will never be allocated with the processor. Active means it will be allocated with the processor. Everybody please connect to the Jamboard. Okay. Now what we have to do is, very first thing, you know that the process you have, somebody please share the link with Vedant. Chat में link है, chat में ही दोबारा डाल दो. So you have file descriptor number 1012. Okay, that are already there in the process context. Now we have to establish this connection which will connect the user space process with the file. To establish this connection between the user space process and the file, we have to create a data channel between this and this, a proper data channel. through which the data say move into the file. This will be the lowest available file descriptor number 3. Now let's have another. Let's take another perspective on this. Another perspective. Suppose this is your internal system database. Internal system data bus, and there are so many files. All the files will be using the same internal data bus for communication. All these are supposed files. Now suppose this file wants to communicate, talk to say this file. Then first we have to create a data channel between these two files. That will be using this common shared bus. Maybe it wants to send the data, that will be read by this. So a common data channel is created between these two. Suppose if you're this file and this file, there has to be some kind of I/O between these two files. Maybe this one. Then you'll have to have the data channel between these two processes. Some kind of data movement happening between these two. If there is some communication required between, say, this file and this file, then you will need another channel in the same shared internal data bus. Maybe the data moves in this direction here. Let's take one more, because we have one more color. So suppose some data has to move between these two files now. Maybe here the data moves both ways. Now, you notice how one internal system data bus was shared among various entities to do their own respective I/O in a common bus. Just like a hotel lobby corridor. Both sides of the corridor you have rooms and rooms, and you want to move from one room to another room, and people want to move from one room to another room. They will keep on moving from one room to another room and use the common corridor. But there are rules of engagement. You see the blue and the green and the yellow, orange and the red. All these are called streams. These are some kind of data channels. some kind of data channels through which the data moves. Every data channel or every stream is like a set of rules which establish the rules of engagement, that how the processes will communicate with each other. Okay. There is something called IO scheduler which will take care of how the internal system data bus will be shared among various entities that will be using the internal system data bus, and every entity that is using the internal system data bus has to create a stream, that is rules of communication. When a data from one stream is put onto the internal system bus, then another process that is intended to use the same stream will only be the process that will pick data from the internal system data bus, and nobody else will pick data. That is how it works. Now, all these things that I showed you happens in the secondary storage. In the user space memory, in the memory there is something called process that you are already executing. In the process, you have already created 0, 1, 2 file descriptors already created, connected to standard input, standard output, or standard error strings. Now here you will create your own data channel. Your own stream. Say you want to communicate with this file. So you will have your own stream created and connected with this file. Maybe for the purpose of writing. So a new file descriptor will be created, 3, and the new stream will be connecting your process with the underlying file, okay, for the purpose of writing. So this is stream, and this is a new file descriptor. 3 is a new file descriptor. This is stream. Data channel. And this is the file to which you want to communicate with it. Right. Now we have to learn how to create this stream. This stream would be created using a system call called open. This stream will be created using a system call called open. Open system call. The open system call will take 2 arguments: the file name and the mode. File name is the name of the file, like for example this file, which has to be connected with, which has to be opened. File name. It is the name of the file to open or connect. Mode. This is mode of operation. Mode of IO means how you want to do IO. The options for mode of operations are, okay, O underscore write only, or O underscore read only, O underscore both read and write, O underscore append, O underscore create. If the file is not there, then create it. So like this, you have few modes of operation. Okay. It will return 0 for success. Means the file is created. Little bit about open, I'll tell you here. About open. Call. It is used to open, or you can say connect with a file in secondary storage. Okay. It creates a stream that is a data channel between process and file. It returns 0 for success to the process for which the moment the process gets 0, okay, process knows that the stream is created, for which the process then the moment it gets 0, it knows that the stream, that is a data channel, that is this one, is created. The process then creates a new file descriptor to connect okay. So new file descriptor number 3 in our case is created to connect with the created file, new file, right? And now the file is said to be opened. Now the file is said to be opened. I hope everybody is able to understand this concept. Let us try to implement this now. So let's see how we do this. We have to use open system call. Look at this open system call first. Info open. There it is. Open system call takes the file name as argument and takes modes. Also notice that we need a FCNTL header file and UNISTD, two header files for this. So let's start with these two header files. Okay, so we need obviously we need the previous header files hash include stdio.h, stdlib.h, uni std.h, and fcntl file control, these header files. Okay, let's start with main. Let's include this header files. Watch this. I will first print the function name, begin. And end statements. Okay. Now I have to open the file. For that I have to give open call. Open call. And the open call will take two arguments. First is the file name. Say my file will be given as a string. Okay. My file is some file in the current directory only. Then I have to give mode _wr only. I am going to open this file for the purpose of writing, where I'll write some data into the file. If the file is found and opened successfully, it will return 0 for success, for which the process will allocate the lowest available file descriptor number, which is an integer number. Okay. There is a possibility that the file may not be opened due to various reasons. If in case it fails, it will return -1. Then you'll do p-error to understand why open failed, and call the exit function with the failure status to get out of this program. So we have to implement the exit function first. So we have to have another file here called declarations.h, in which you declare your function, exit function. The argument is char star status, which I have given failure. So in main you include your declarations.h also. Declarations.h included. Now we have to implement exit function first. Exit function. Here it is. Exit function char star status. So we'll check if strncmp, we are comparing if the status is success, then we will compare it for SUCCESS 7 characters. If there is no difference, then it will return 0. Then you will do exit, exit, success. If in case there is failure, then you will do exit, failure. That's it. Now your exit function is done. If your file is opened successfully, you will reach line number 15, where you would say file opened successfully, and the given file descriptor is the lowest available file descriptor number. We'll try to print it here. Okay, let's see how it works. Let's save all the files and see if we are able to open the file. We have to write make file for it. Bin bash. We have to write file IO program from main.o exit function.o. File IO would be created by using the rule gcc, the optional name file IO, main.o, main.c, address.h, declarations.h, gcc -c, main.c. Then you have the exit function. Good morning, sleepyhead. Exit function. Okay, so now your file IO will be done and the file will be created. So this data channel, stream of data between the process and the file in the secondary storage, this data channel will be created and it will return 0 for success, for which the process will allocate the lowest available file descriptor number 3. Let's see this. Let's make implicit declaration of function strncmp. So we'll need a header file, string.h. Done. We have file IO created and let's run. We run it, it say open no such file or directory, fail. We ended up here. The error says open system call says no such file or directory, means the file or directory that you're going to create my file is not there. So let's create it and now run. Oh, there it says file opened successfully, FD is 3. We got a file descriptor which is 3. So file is opened successfully. Yeah. Touch is not a keyword. Touch is a command which is used to create empty file. Once you have finished working with the file, then you have to destroy this green color stream and disconnect the process and the file. Okay, and this disconnect is done using close call, close file descriptor. The close FD will destroy the stream, connecting the process context with the file in the secondary storage. Okay, and then you can finish IO. This is all I got for you guys for file IO, and there are documents in the EmbLogic application. Please go to the application and see the documents there. And don't see, there are two ways of doing file IO. One is ordinary file IO implemented through C library functions. Another is low level file IO. So I am telling you low level file IO, and I'm not telling you anything about the file IO implemented through C libraries that you have to read yourself. That will be easy. So when you read the documents for low level file IO, and when you do programming, you do it for low level file IO, because this is how it is done in embedded systems. Okay. Yes, Vedant, tell me.